makes?
Magnetism, I heard. What else? Electricity. What else? Electromagnets. Electromagnets are the combination of magnets and electricity. We talked about two different types of magnets. The first type of magnet that we talked about was just a plain old rock that attracted iron. Okay, remember they discovered it back in Greece. That's just your standard everyday magnet. This one is painted blue and red for the north and south poles, but we know that it attaches to all of the magnets. Okay, or it attaches to iron and collects iron paper clips. Things. Paper clips. That's what I'm trying to think of. Paper clips. Okay, so my question for you is, if this is a magnet, why are these paper clips down here sticking to these paper clips up here, even though the paper clips are not magnetic, right? The paper clips aren't magnets. Why are these paper clips that are dangling down here on the bottom, they're not touching the magnet at all? Why? Why are they still attached to the whole group of them without falling down? Nate?
It's a temporary magnet.
It's a temporary magnet. Very good. Okay. The paper clip, because of its proximity to the magnetite, becomes a temporary magnet. Okay, which allows it to then attract all of the other paper clips. Okay, so each of these paper clips becomes a temporary magnet because of its proximity to the magnetic field with the magnetite. Okay, so that was the first type of magnet that we talked about. We talked about another type of magnet called an electromagnet, and it needs three main ingredients, three main things. Okay, what are the three main things that we need to create an electromagnet? Give me one of them.
Electricity.
You need electricity. That's the electro part. Okay, what's another thing?
Wires.
You need wire. Okay, you need some kind of wire. What's the last thing that you need? This is the one everybody forgets about for some reason. Something metal, some type of iron. Usually is what we use. We usually use iron. Okay, so here I have my wire. Okay, it's coiled around this iron nail. Okay, so there's my iron, got my wire, and I have my electricity. It's my battery. All right, so if I attach this should be an electromagnet, correct? Yes, no?
Yeah.
What do you think? Yes. Okay. So let's see. This one, you can kind of see it moving. This is not very strong. Okay. So it kind of moves a little bit. Let's see if we can get a better connection there. Maybe that'll work. Okay, you kind of see it picking it up, but it's not really staying. Do you see it kind of picking it up there?
Yeah.
Okay,
Yeah.
so it's kind of picking it up, but it's not really staying. What can we do? There were two different factors that we could alter in order to create a stronger electromagnet. So what can we do to make this, what is one thing that we can do to make this magnet stronger?
Coil the wire around it more.
Okay, put more coils on our magnet, on our iron. That's very good. Okay, so now we have, see, the only difference between this electromagnet and this electromagnet is how many times I have the wire coiled around the iron. Do you see that? Okay, so let's see if we can get this one to pick up a few more. This one's kind of hard because it doesn't, see if we can get it to pick up better. My wires are too short. They don't reach very well. So let's see if we can get this to work. There we go, look at that, much easier, right? Stronger just because the only difference between this magnet and this one, I use the exact same battery, the nails are exactly the same, came from the same box. Okay, the only difference here is that this one has a lot more wire wrapped around it than this one does. Okay, so more wire means more electricity. More electricity means a stronger magnetic current. Okay, so big battery. That's the other thing that we can change, right? Okay, so we had the little tiny battery and we put more coils and that created a stronger magnetic field. Now, we've got a larger battery, a stronger battery. Let's see. Is it this one that we were doing?
Yes.
This one we have, it's basically the same thing. It's just a larger nail. It's got the same kind of coils underneath that black tape. We just covered it up with black tape to keep the coils in line and keep them from. And it's much easier. Look at that. Let's see if we can. Okay. Much easier to pick up our paper clips. We've got all kinds of paper clips on the end there now, and it doesn't have anything to do with the fact that it's a giant nail. Okay, we could have attached this to our battery. It just didn't have enough wire. We couldn't have attached it with our wires. So we have this giant battery, okay, and the giant battery is causing a larger magnetic field. Okay. All right. So those are our two different types of batteries, or I'm sorry, the two different types of magnets that we talked about. The regular magnetite and the electromagnetic, electromagnets.
All right, Miss Winford and I, for our next demonstration, are going to have a race. Okay? So Miss Winford and I both have copper pipes, which are the same, other than hers is a little bit shorter than mine. They are the same.
One.
Okay.
No, I want the shorter one.
Okay.
Okay, I'm good.
There we go.
Sorry.
You sure?
Yep, I'm good.
Okay. So they're the same diameter. Okay, so nothing is changing in there. Is there anything inside of there? No? Are you sure? Is there anything in there? Am I tricking you? Is there anything in Miss Winford's? You see? Is there anything in there? Okay, Miss Winford and I also both have a steel sphere. We're gonna have a race. I'm gonna drop mine in here. Miss Winford's gonna put hers in there, and we're gonna see who gets to the bottom first. Are you ready?
Wait, hold on, Ben.
Well, that
Who's gonna
does not
win?
sound excited.
Miss Norris.
Raise your hand if you think I'm going to win. Miss Norris. Raise your hand if you think Miss Winford's going to win. Hers will come out first.
Come on, people. Come on. All right.
Okay, count us down. 3, 2, 1. Wait for it. Wait for it.
Woo! Okay. Same size sphere, same size diameter, copper tubing.
You know what? That is cheating. 3, 2, 1. You all are so empty.
Oh man, sorry.
Sorry. Let's try this again.
Okay.
3, 2, 1. Wait for it. So why is Miss Winford winning and I am losing? Someone raise your hand so we can hear you. Okay,
Has something to
Sadie,
do
what
with
do you
the
think?
ball?
The little metal ball that you have is magnetic.
The one that I have is magnetic?
How do you know hers is magnetic? How do you know mine's not magnetic?
Because that one's just dropping straight through, and that one takes forever to fall down.
But why does that make it a magnet?
Because it's like wanting to stick to the metal.
But is copper magnetic?
No.
Something to do with like the ionic bond or something. I don't know.
Let's get that.
Copper is a conductor,
Oh,
so the magnetic ball is making or the ball is making a magnetic field inside of it. Or the electric field is making a magnetic field inside of it.
Okay, good. So what she's saying is that because we have a magnet, when we have a magnetic field, we are also creating a very strong electric current, an electric field that's going through this. So yes, you all caught me. Mine is a magnet. I'll show you. We're super careful about this. Okay, mine is a magnet. Not only is mine a magnet, but it's a super strong magnet. Okay, you don't want to put this thing next to your phone. You don't want to put it next to like a credit card or a gift card with that magnetic strip on the back. It'll ruin it and it won't be able to work anymore. Okay, we have to be really careful with this guy. Okay, we have to be careful with what we do with it. Okay, so when we put it into the copper pipe, it creates this electric current. The electric current on the copper pipe kind of feeds our magnetic field. So the magnetic force is actually pulling our magnet upwards. So why does it travel down?
Gravity.
Gravity. Good. So our magnetic field is keeping it pulled up, but there's a fight in this tubing between the magnetic force that's pulling up from the electric current and the gravity that's going to pull it down. Okay, that's why it goes really slow, because it wants to stay up, but gravity is going to pull it down, and eventually it comes to the bottom of the copper pipe. You good?
Perfect. Yep. All right. So now I'm gonna steal Miss Norris's. I keep wanting to call her Miss Winford. I don't know why. I'm gonna steal this nifty little magnet here. Okay. And I'm gonna use my little slime. Okay. How many of you remember making slime when you were like in elementary school or maybe in middle school? You probably made some slime. My slime. Listen.
That's my childhood.
This is your childhood?
No, Play-Doh.
Play-Doh?
Slime
Mine is
is
way better.
Yeah.
We made Oobleck.
You made what?
Oobleck.
Is that like where you push at the can and it like farts or whatever?
No, Oobleck is like.
That's kind of like the consistency of
That's
this.
what this is basically, but mine has a special ingredient.
It's magnetic.
Oh, yeah.
Okay. This is my slime, but it has a special ingredient that makes it magnetic. Okay, so if you see, it does look weird. The color of it, it's kind of like a grayish kind of color, and that color comes from the iron filings that I put in it to make it magnetic. Okay, so that's why it kind of
Why did you put the ball in the bag?
because if it gets lost in there, it's really hard to find again. So seriously, yeah. We'll actually let it. We'll let it eat it. Watch. See, the magnet is going away. We're not going to be able to see it here soon. It has nothing to do with me. I'm not doing anything. I'm just holding it. Okay. Oh no, there it goes. Okay, so if we just let this sit for a minute, what's going to happen is we're going to see that something strange is going to happen to our slime. Okay, not just to our magnet. It did eat our magnet, so we'll kind of.
And pull him back out, put him on the side.
Yeah, we'll kind of. Here. Okay. So everybody pay attention. Actually, you know what? You can kind of already see it. Well, we'll let it sit for a minute. Let's let it sit for a minute. Okay. So here's our whoopsie. Okay. So now, this is the same stuff. It's just a different color. It has a little bit less iron filings in it, but it's the same stuff. Still nice and goopy. You guys want to pass this around? You want to touch it?
This is a disclaimer about the goo. If it touches your clothes, it will soak in, and it won't be able to come back out.
So don't put it on your clothes.
Just your hands.
It's not just the goop that's magnetic. It's the filing that's inside. All right. What do we have next?
Spinner.
Spinner thing, yes.
All right.
That's all you do because I break it. Listen. Make sure you're paying attention.
Okay. For this one, I'm not going to tell you how this works. I want you to watch and make some observations, and then we can talk about it. All right, make some observations about this.
Spinning.
It is spinning.
Mr. Capizzi had one.
Very good observations. Turn to a shoulder partner. You have 30 seconds to talk about what makes this work. Give me an explanation. Yeah.
One side of the magnet
them off.
Just wipe it like that.
There you go. Take them off, Eli.
Does she like make
Thank
this
you.
out of like the glue?
Glue and liquid starch.
Stop.
Who's your elbow partner?
I was talking to Nicole about it.
Why don't you two talk about it? Hi, this is Jared. He's going to be your elbow partner. Okay, let's come back together. Come back together. Someone give me an explanation as to why this spinning top, we're going to call it a horizontal top because it's not our usual like tops that you spin on the table. So why does this work? How does it work? Yeah. With magnets. That's a really good guess. So can we be a little bit more descriptive? Yes, Rachel.
Maybe like there's two north ends together on one end and two south ends together on the other, so they're resisting each other, so that's why it's floating and spinning.
Okay, so yes, Rachel, you're correct. The reason why it floats is there is two magnets in here. I don't know which one's north and south, but you're going to have two north poles or two south poles that are repelling each other. They don't want to be next to each other. On the other end, you have two north or two south poles. They're also repelling each other. And that is how it hovers in the air. Okay? Does anyone have any guesses as to why when I start spinning it, it just kind of stays where it's at? Why doesn't it go anywhere? Yeah.
It has something to do with the shape.
Okay, maybe it has something to do.
The like angle.
Okay, the angle. I'll tell you that on these two big parts right here, there are two magnets that are circular that are standing straight up. So what else? What else do we think? Why doesn't this thing go anywhere? What about it? Okay, so maybe one's pulling it towards it while the other one's pushing it away. Turns out the secret to it staying there is a little bit less complicated than our magnets. This end has a small metal pointed end, and it just sits right on the plexiglass. It is flat. There is no holes or anything in it. It just sits right on the plexiglass, and it spins. That way it doesn't go anywhere. It has something to kind of push against. Okay? And that keeps it all in one place so that it has somewhere to stay. Without it, it falls. But it is magnets. I'll come around and let you all kind of feel this. Or hold that.
Doing that, the spinning motion that happens with the spinning toy thing there that we've got is the same thing that happens inside. We talked yesterday. Listen. We talked yesterday about some motors, electric motors. Electric motors work in the same way. They have that spinning motion. They have that spinning coil. This is an electric motor. From the electricity that you see, or that you get from the battery, okay? If we can get this to, now if these little things are nice and straight, then we can kind of get this little thing going. There we go. Okay, so this is basically the process behind what happens inside like your toy car. Okay, if you have a remote control car, or if you have some other kind of electric motor inside your generators, this is essentially what is happening. Okay, it's spinning, it's causing, there's an electric current flowing through, please. There is an electric current flowing through these copper plates on the side that is transferring it to the copper wire in the top. Okay, that's creating a magnetic field within that wire, and then there's another little magnet right on top that is affecting that magnetic field and causing it to spin. Now we probably couldn't run anything off of this motor. Okay, it's probably not strong enough for us to actually power anything off of, but essentially it's the same thing. The same thing's happening. All right, let's go ahead. That's actually going really good. I'm going to leave it there. I wanted to go ahead and show you what happened to my slime. It lost its color. gray anymore. Remember, it started out this color. Okay? Yes, all of my iron filings are now attached to my magnets. Okay, now this is no longer magnetic slime. Sad. All of my iron, until I put my iron back into it, all of my iron is right here. It was all attached to my magnet. I had to pull it back off of it. So, kind of cool. Magnetic slime. That's pretty much the gist of it. This magnet is super duper strong. It can even pull filings out of magnetic slime. All right, so next up we have our electromagnets, right?
So before we did these small electromagnets, which I'm going to disconnect, it's getting a little warm. So we had these electromagnets before, right? What could these pick up? Paper clips. So let's say that we get a different iron filing, or not iron filing, sorry, a different electromagnet that's a little bit bigger, okay?
A little fancier. We didn't make it. It came made for us. So it's a little fancier. It still has the copper wire wound around it. Okay, that's what these things here on the ends of the horseshoe are. Okay, the center, the iron middle is right there, going through the center of the copper coils. All right. What else did we need? We have our piece of iron. We have our copper coils. What else did we need?
Electricity.
Electricity. That's what makes it an electromagnet. So we have our battery that's going to power it. Okay. So let's see how.
Let's bring it down a little bit.
Oh, there we go. All right. So this is probably, I'd say it's kind of a medium-sized electromagnet. It's definitely going to be stronger than the ones that we made with the nails, right? Because look at all those coils. Look at all those copper coils. Okay? So let's go ahead and we're going to test it first.
You want to try?
Oh, yeah, let's do paper clips. That's good. Okay, let's see how many.
So before it took our biggest electromagnet with the nails to just pick up some of these paper clips, whereas now
we've got them all. Okay? So it's definitely a lot stronger than the one that we made with the nails. Okay? So here's this one. This is one of our, now this isn't the magnet, okay? This is just the steel sphere that we dropped through and it fell through just fine, okay? It kind of sticks on to the end of that magnet. Brooke, pull that ball off. Okay? Was it hard? A little. So, like, you could feel it, but it wasn't so hard that, you had to put some real muscle into it, right? What do you think?
Same thing.
Same thing? It was, so you didn't have to put real muscle into it, but it's probably harder to pull off than, say, a refrigerator magnet. What do you think? Okay? All right? So, that being said, if we've got this electromagnet that is, it holds this, and it holds it pretty good, but it's not real super difficult to pull off. Okay? This is probably, I don't know, 2-3 grams-ish, something like that. Now I've got this great big one. Okay? Somebody who felt, Brooke, take this. You felt the other ball. Do you think that one this magnet will hold that? You don't think so? What do you think?
Yeah.
You think so? Pretty heavy. What do you think? You didn't feel the other one, but what do you think? Pretty heavy. It's heavier than it looks, isn't it? Anybody else want to feel it?
Yeah, I do.
You don't think so? Okay. It's not a super, who said over here?
Me. That was me.
I think that's pretty heavy.
It's heavier than it looks. All right. What do you think? You think it's gonna hold it?
It's like a little mini bowling ball.
It is kind of like a little mini bowling ball. All right. So let's check it. Let's see. Ta-da! Okay, so with this giant magnet, or I'm sorry, giant battery on here, this magnet is probably a little tougher than what you think it is. Okay? It probably wouldn't hold much more than this. It's pretty precariously perched on there. Okay, so it's probably not going to hold much more than this, at least with just one of these batteries. Okay? If I wanted to increase the power of this magnet, what would I do?
Get a bigger battery.
You get a bigger battery, I heard that.
Get a bigger battery, I could do that. What else could I do? Put another battery, I could do a series of batteries.
What else?
Remember, think about what you guys, when you guys were doing the snap circuits and things like that, and you added more batteries. Okay, or if you did the light bulbs. Okay, and you put a bunch of light bulbs all together, you got a really bright light, right? Because you had more electricity. More electricity is going to give you a stronger magnet as well.
Take those off.
You want to introduce the next one?
Yes. So this one is another electromagnet, and it's just a little bit bigger. So this one, you can't see the coils because they're hidden inside of this, the black container part down the bottom. And this part is going to stick to the bottom. This is not a magnet. Show you. Doesn't stick, okay? Doesn't stick. It's not magnetic. So the only way that this can become a magnet is how? Electricity. Okay, if we get an electric current to flow through the little adapter for our magnet, then this will turn into a magnet, because this is not a magnet either, okay? It won't stick unless we have current going through there, okay? So, we go ahead. Miss Winford's gonna hook it up for us.
All right, are you ready, Miss Norris?
I think this one's not on, this yellow one.
Oh, yeah, it's not. Let's attach that one.
Okay, so she's gonna use the same size battery that we've been using.
Same size.
Okay. So this is a pretty strong electromagnet. Okay. It is a little bit larger than the one we had before. So definitely you can totally feel this one when you go to take it off. You got to give it a real good tug before it actually will come off. Okay. So we have to make sure that, get this center. I didn't put it on center. We take that off. Thank you. Okay. All right. So I need a volunteer who works out.
Volunteer too.
I need a volunteer who is constantly lifting weights.
He doesn't work out.
I do work out.
Who do you think, Miss Winford?
I don't know. Let's get Chris. Chris, come on up.
Oh,
Hold on. We'll have a couple people. We'll have a couple people. Don't worry about it.
at 6:15 a.m. Field house.
Okay. So let's explain this to you, Chris.
So did Ainsley.
These, we had to set this up with some weight on top so that they don't move when you pull on it. So when you pull straight down. Don't pull towards you,
forward or
because
backward.
these will fall off on your head.
You're going to pull on this
Do
ring
that.
right here.
Alright.
Okay, so you're just
Right
trying
on
to
the
separate
bottom.
that little thing that Miss Norris just attached. You're trying to separate that from the main thing there. You can touch this if you need to, hold on to that. And
So he's going to attempt what I just did. What are you talking about? Come on. I did it.
oh, come on.
Oh,
I don't believe that.
hey, let me
All
try.
right, hold on a second. Let's try this again.
Okay.
Come on, Chris.
Go ahead.
Try it one more time.
This one for let me over here.
Hold on a second now.
Did you work out this morning?
Yeah.
I did.
Here, let me
All
try.
right, come here, Skyland.
Chris, oh my God, this guy gets me.
All right, go back, Chris.
Chris, just remove the wire. Remove the wire, you got it.
No, don't remove the wire. That breaks it.
What am I doing?
Okay, you got to take this ring.
And just
okay?
pull straight down.
Straight down.
You think you can do that? All right, ready?
Yeah.
1, 2, 3, go. Ooh. What the heck, Chris?
What's going on?
You can put it back. Center it. Will you take that? Will you unhook that so she can put it back? All
All
right.
right, now center it.
Ah, you cheated.
No, you have to unhook it to put it back.
Unhook it to put it back on straight.
There you
Is
go.
it on there? Yeah. All right. Whew. All right. Come on. Let's see what you do.
Pull straight down.
Straight down.
Not that way, straight down.
Holy crap! What the?
Come on, Eli. All right. You're going to break the board.
I'm gonna break that board.
Okay.
You did something to that.
Come on, Casey. All right, ready? Go.
All right, now hold on.
Are you
Hold right
pulling?
here, and
Hold
then-
that and
yeah,
pull it
hold
straight
that
down.
there.
Ready? 1, 2, 3. Pull. Oh, nice. All right,
now
take that off so you
this
can
is
put it
off.
back.
Okay, so go ahead.
Put it back. There you go.
All right.
Nice.
All right.
Thomas, come on, Thomas.
Do what?
Thomas is coming. Clueless. All right. You gotta pull straight down.
Now, if you feel our board bowing,
Like,
be careful. Okay, now hold on. Try holding right here. That's what the girls
hang on, wait. Don't disconnect the wires.
connect their wires. Just hold there
And pull.
That's what the girls have done, and that's worked.
Oh, careful.
What in the heck? All of these boys.
All right.
All right, Aaron, come on. There we go. What?
All right, go ahead.
All right, it's on there.
Okay,
All right, who else? Anybody else?
you get one more.
One more person.
Go ahead, pick them.
All right, come
Pick our last volunteer.
It seems to be a lot harder for the boys. I think it has something to do with that Y chromosome.
So wait, where am I?
Seems to be a lot harder for them. Okay, so hold on to this right here and pull down on that.
Straight down.
Straight down on that thing.
Okay, ready? 1, 2, 3, pull.
Pull
Pull.
hard. There you go.
Ooh. Oh, the green one came unplugged.
All right.
Oh,
All right, go ahead. Here. Let's do this. Stick it on there. Just like this. Got it?
yep.
Whoops. Hold on.
Oh my gosh.
I know. All right. Listen. Shh. I have a confession to make. Some of you have already figured it out. All right. I was unplugging it when the girls came up.
Oh, plug it.
No, it wasn't.
Okay.
Wait, did you unhook it when Thomas did it, or Thomas?
No, Thomas was just a freak of nature. That's all right.
Okay, so
So we have a couple of weights that we're gonna try this on.
3 pounds.
A 3-pounder dumbbells.
That's what my
Okay.
5-year-old brother does.
Those are mine.
All right.
Those are mine. I will admit
So
that.
now, this electromagnet, listen, this electromagnet could barely hold up this probably 2-3 pound-ish ball, okay? This is about 2-3 pounds. So now this is a 3-pound weight. Do we think that this is going to hold this 3-pound weight?
Yes.
Okay, you guys sound pretty confident in that. Let's go ahead and do this one, okay? Ta-da. What if I add another one?
Yeah.
Are you sure?
Yeah. Thomas is 150 or whatever he is.
I'm probably.
But it wouldn't really have to do with his weight. It was more he was pulling on it pretty good. All right, so let's see what
It's not.
Ooh, it's working. Now this is just with one battery, remember? You only have one battery hooked up.
So think about this. The other electromagnet is not that much bigger than this electromagnet. So we're already holding at least 3 times as much weight with this one than the other one. And it's only a little bit bigger than the first one that we used.
And we're using the exact same battery. Or not the same one, but the same kind. Okay, and they're all brand new. It's all the same. Okay.
You know, Miss Winford, I think that we gotta give the people what they came here for.
All right. Okay, so we've got, listen.
Do you all think we should add a lot more weight?
How about a 25-pound weight?
Why not?
Is it going to hold it? Oh, man.
Yes.
This thing is really heavy. Can I hold it? I mean, I have a 30-pound kid. What? With both hands. Okay, so let's see. Miss Norris is going to help me out here. Let's see if this is going to hold this 25-pound weight.
Can we get a drum roll?
Let's see. Woo! All
Nice.
right, so it holds 25 pounds. That's pretty impressive, right?
All right, time for your quiz. No?
No quiz? Your quiz. Yeah, like a paper quiz, like we have one for you. No?
Why not?
Because I don't want to a no grade quiz.
Yeah, let's do it. Let's do it.
Because quizzes are stinky poop. I don't like that.
Is she lying? Do you want to do another one?
Yeah.
Do you want to put another 25 pounds on here?
You think you can take 50?
Yes.
I think.
All right.
All right, let's try. Let's try this, Miss Norris.
Drum roll, please.
All right, here we go. Oh, be careful, Miss Norris.
It'll hold 100. Are we gonna put the other ones
All right.
on
I don't know about that. I don't know.
now? We should put one more.
Well, I mean,
One more.
you would have them there.
Well, we had him here to hold
Hold the
bench thing
Making it
down.
board.
people to come up and bring it down.
I'll sit on top of the box. You're gonna sit on top.
You're 100 pounds, so you'll sit on top of the books.
Oh, well, you know what? It's Miss Winford's room, so we're going to do it.
Okay.
We should put on-
Throw me under the bus.
Drum roll for 75 pounds.
Oh, Miss Norris, please do not hurt me. Woo!
Nice.
All right. Another one?
Yeah.
Miss Norris, I don't know about this. This is getting a little out of hand.
Think about it. Let's just
Let's
stop.
think about, stop, hold on for just a minute and think about how much weight.
Think about it. We maxed out this one
With the same battery.
with this little boys. With this little 2.5 pound weight. We completely maxed out our electromagnet. Look at the size comparison.
Not that much different.
So think about that, 75 pounds. To me, that's mind-blowing that we've already surpassed exponentially the amount that we thought it should carry. And a little confession, Miss Winford and I were prepared yesterday when we set this up to use all of these batteries together to hold up these weights. Because even we didn't believe that this one battery would hold 75 pounds.
We should do one more.
Okay?
What's it gonna hurt, Miss Norris?
All right.
Might as well.
All right.
We've gone this far, but you know what? If one of us gets hurt, we're totally coming after y'all.
Hey, it's on.
Hey, and then you can put Jada on it.
Put Jada on. I don't know about that. I'm not gonna
All right.
risk a student. All right.
This is the 100-pound drum roll.
Oh, that was
weak.
pathetic.
There we go. Be careful, Miss Winford.
Okay.
Ready, go.
Woohoo!
Nice.
Listen, it is holding 100 pounds. So one Jada, we could hang Jada from this, and she would be perfectly fine. We're not going to. No, don't ask. But it is holding 100 pounds. That tiny itty bitty little magnet, okay, is holding 100 pounds, and it's very reliant on these simple little wires. Okay? All of that electricity that's flowing through there is creating that magnet that's holding on to this piece of metal that's holding all of that weight. Okay, this is a lot of times how they test magnets. This is the same type of magnet that you're going to see in a junkyard, okay, that picks up a car. This, I would not be surprised if this could pick up a small car. I don't know. We don't know. Miss Norris and I, confession, we knew it was going to go 100 pounds. We're just really good actresses, right?
Sure.
So when we were setting this up yesterday, I went home and I started thinking like, man, I wish I could find what type of electromagnet this is and figure out like how much is it supposed to hold. Did we just get lucky and it held 100 pounds one time and it's only supposed to hold 50? I don't know. So I went home and I started doing some research on things and I couldn't find one that was just like this, but I found a video of a professor who made his own electromagnet. Disclaimer, do not do this unless you're a professor and know exactly what you're doing. But he took apart a microwave and he harvested some parts from this microwave to make his own electromagnet. This magnet and the weight that it was going to carry sat on the floor and he had to use a winch. So when he turned it on, it would wind up the cable and lift it up off of the ground. He had to use a winch because this electromagnet, which was maybe twice the size of ours, it was holding 2,000 pounds.
Oh, can we watch the video?
So basically,
Okay.
Yeah, it's a car, bigger than a car.
That's a lot of weight for just one electromagnet to carry. So that's why it's good uses for things like the junkyard. They'll turn on the electric current, it becomes a magnet, they can pick up scraps, move it over to where they need it, turn it off, and it'll fall off. When you disconnect the electric, you no longer have a magnet and it all comes crashing down. So electromagnets are super, super useful in our everyday lives, okay?
This is something that you probably have used and you don't even realize it. For example, when you use all of those electric motors that we were talking about before, this is the kind of magnet that's inside of it. Okay, that's it's turning on that electric current. It's making that electromagnet spin. Okay, that's what's giving you that mechanical energy that's being transferred into whatever you're trying to get your motor to do. Whether it be run a car, like a little remote control car, or to blow up your whatever you want to call it. Okay, so we have a very quick listen. Shh, you are not finished.
Please listen specifically to these instructions. I want you to follow them carefully. You're going to get out a pencil. If someone around you doesn't have one, use yours and share. You can write a pen as well, okay?
Let's not throw things across the room.
Please don't throw, Keegan. So if two people want to write on a desk, that's fine. You need to fill this out on your own, okay? And then just stay where you are and on your way out. So after the bell has rang, not before, after the bell rings, you will hand it to Miss Winford or myself on your way out.
Yes, ma'am.
Capiche?
Oh, wait, what?
Miss Winford, you want to take some of those?